So welcome back to another section of my YouTube channel tutorials. In this video, I'm going to take you through polar coordinates. So we are familiar with Cartesian coordinates, right? So Cartesian coordinates are the basic coordinates we are exposed to in elementary schools. When I say Cartesian coordinates, when you draw your x and y axis, that is your two-dimensional plane. You have your y-axis and your x-axis, right? Any point within this plane is what we call the Cartesian coordinates. Okay, Cartesian coordinates. In this tutorial, I'm going to take you through polar coordinates. So what makes this coordinate called polar? Okay, so when we say a polar coordinate, it's an upgrade on Cartesian coordinates. Okay, so you draw your Cartesian coordinates, and you know that Cartesian coordinates, you have y-axis and x-axis, right? Now, when I have a Cartesian point, this point will be represented as xy, right? Yeah, so in polar coordinates, we are not interested in the magnitude of x and the magnitude of y as it is, but rather we are interested in the distance of this point from the origin O, here O. So the distance from origin to the point of reference is given as r. That is the magnitude. Again, in polar coordinates, we are interested in the angle this particular line is making with the positive x-axis as theta. So you realize that polar coordinates, we have two parameters, what is r, theta, and that is what we are interested in. So the conversion of Cartesian to polar coordinates simply maps to xy is given as r, theta. Take note, where theta is the angle the line joining the origin to our point makes with the positive x-axis, and where r is the magnitude of that particular line joining the origin to the point xy. Having that said, let's see how to represent certain polar coordinates. But first of all, I'm going to give you a Cartesian coordinate. So now, convert the point 3, 4 into polar coordinates. So how do I convert the point 3, 4 into polar coordinates? This means that I'm to find the magnitude of this point from the origin, as well as the angle that particular line will make with the positive x-axis. The first thing to do is simply draw your Cartesian plane. Then you locate 3, 4, right? So here is 0 origin. So let's assume the x-axis here is 3, and let's assume that here is 4. So our point 3, 4 will fall here. Is that not it? Then we will join this to the origin. So I have point 3, 4 and the origin. So my r is simply giving us the square root of 4 minus 0 all squared plus 3 minus 0 all squared. You realize that when I join this line here, the end point of the line is given as 0, 0, that is the origin. Then I also have 3, 4, right? So to find the magnitude, I just take 3 minus 0 all squared, 4 minus 0 squared, and that is what I've done here. So what am I getting? The square root of 4 squared, 16, plus 9. That is going to give me root of 25, which is 5. The next thing is to find the angle theta here, which is the angle this particular line is making with the positive x-axis theta. So angle theta is always given as the tan inverse of y on x. In this case, what is our y? Our y is 4 over 3. So the tan inverse of 4 over 3 gives us the angle theta of our polar coordinates. The angle theta of our polar coordinates. So tan inverse of 4 over 3 is going to give us 53.13. So I'll get theta to be equal to 53.13 degrees. But normally, it's advisable to leave your answer in pi radians. Degrees is also right, but depending on what the answer is or what the question is expecting, yes, or what the question is asking you to do, you can either leave it in degrees or pi radians. To convert this to radians, pi radians, you just have to divide this by 180. So 53.13 over 180. Okay, so it's simply divided by 180 and you're getting 0.295 pi. So that is how we convert a Cartesian point to a polar coordinate, right? So let's do the other way around. Now I'm going to give you, so convert the coordinates 2 comma pi on 6 to Cartesian coordinates. Cartesian coordinates. So now we are going to convert this coordinate, which is obviously a polar coordinate, to a Cartesian coordinate. So how do you do that? Simply you draw your Cartesian plane, but in this case you will write your origin here and you realize that the distance here is what? 2, right? The distance is 2. But now we have our angle to be pi on 6, where pi on 6 is the same as what? 30 degrees, right? So our angle is 30 degrees and our magnitude is 2. If you want to reverse polar coordinates to Cartesian coordinates, what you are going to do is you are going to use the trig ratios. So you assume your r, which is 2, right? R equals 2. Then now the angle is making here is 30 degrees. So what is my x? What is my y? My x is simply equal to r cos theta. That is the horizontal component of my r. Then my y is simply equal to my r sine theta. So this gives me 2 cos 30. Then this gives me 2 sine 30. So what is the respective answers? So 2 cos 30 is giving us square root of 3. So my s is equal to square root of 3. Then 2 sine 30. Sine 30 is half, right? So we are going to get y to be 1. Therefore, my Cartesian coordinate becomes square root of 3 comma 1, right? So at this point, I've introduced you to polar coordinates, how to convert from polar to Cartesian and vice versa, right? So thank you, and that is all for this video. Hope seeing the subsequent videos. Don't forget to subscribe, like, and share.